So we're gonna go on a little journey, and we're gonna look at some triangles. So this journey starts off with just trying to get a sense of what's going on here. Let's say I had a right triangle, and it's got a 20-degree angle over here, and I go out 5 feet this way. How far is this side gonna be? Okay, well, we know that the ratios of these sides are predetermined for a 20-degree triangle. In other words, it doesn't matter how big I draw a 20-degree right triangle, this side and this, I gotta switch colors. Gotta do it orange. This side, orange side, versus blue side is always going to be the same. Now you might be saying, wait, the orange side is bigger than this. Yeah, but the blue side is bigger than this. In fact, they both got bigger at the same rate. So no matter what the size of the triangle is, the ratio is the same if this angle is 20. All right, let's get back to our triangle. Choop, choop, choop. What is that x? Well, if someone could just figure out what that ratio is, then we could set up a ratio like some. So there's a special ratio for 20s, special ratio for 20 degrees, and it's going to be equal to, I'm going to make the ratio the unknown side over this side. Special ratio for 20 degrees. Well, they actually named the special ratio of the opposite side versus the adjacent side, and they named that the tan ratio. So there's a tan ratio, a tangent of 20 degrees. And what is it? I could go get a book and look it up. I could go talk to someone who's calculated it by hand. But we'll just look it up on our calculator, and it says the ratio is 36.4 versus 100, also known as 0.364 approximately. So I wrote it as a ratio because we call it a ratio, but then actually your calculator spits out this decimal. So let's back it up and use that. The special ratio for tan 20 is 0.364 approximately, and that's equal to x on 5. And if we multiply both sides by 5, times 5 times 5, this side's 5 times bigger, so we don't need to divide by 5 anymore. We get x. This side's 5 times bigger, 5 times that, 1.82 approximately. Whoa, this side's pretty small. 1.82. This side's 5. Well, this is only 20 degrees. And 20 degrees, I think, is maybe smaller than that. I just, it's geometry, so you can just draw the angle however you want if you label it. Okay, so try a little attempt to get more realistic here with the orange. So that's what my triangle looks like. This distance is 1.8. This distance is 5. Pretty great. What's this distance? Whoa, question marks all up in here. Let's erase this last question mark. The last question mark was just what's the ratio, which we looked up as a tangent. Ratio. This question mark is what's the hypotenuse? Well, thanks to the most proven theorem of all time, we know that if you take this side, the 1.82 side, and you square that, and then you take the 5 side and you square that, it's going to be equal to the question mark, but squared. All right. I still have the numbers in my calculator. I'll round this off at 3.31, I guess. Plus 25 equals question mark squared, also known as c squared. 28.31, 28.31 equals, I'll change to c now, c squared. And the best part is square rooting. And and reflexive property, switch it around. C equals, I have to actually look this up. Square root it. 5.32. 5.32. Move over question mark. We now have our answer. Sweet. Now we're trying to learn. So what's the point of this? We're trying to learn something about triangles. So let's make this table. Hypotenuse, the adjacent, the opposite, and the angle we'll call theta. We figured out this is 5.32. The adjacent was 5. The opposite was 1.81, I think. Theta was 20 degrees. Cool. Let's figure out another one. I know, let's keep theta the same, but change this to 6. Well, now that's inaccurate. Tan 20 times 6. Now this other side is, oops, broke it.